Dark matter. I'd like to talk about dark matter. Dark matter is something that our scientists made up. And the reason they made it up is because they needed something to explain why some stars are going faster than our science says that they should be going. Now, our science says that the further out that you are orbiting around something, the slower you must go because the further you're going. And that's how it works for the solar system. And so dark matter was invented originally by a guy named Fritz Zwicky in 1933. And he was looking at what they call old globular clusters. And there's a spherical shell of old globular clusters around every galaxy. Actually, it's a double shell. There are two shells, nested spherical shells around the galaxy. And Fritz Zwicky was looking at these globular clusters, and he could see that they are going a lot faster than what he figured was possible. That they, at the speed that they were going, he thought that they should just go shooting off out into space rather than stay with our galaxy. So he was puzzled about this, and he came up with the idea that maybe there was an invisible matter that was pulling those stars along and keeping them going faster, you see. And that idea didn't gain a lot of traction, but all through the 30s, 40s, and 50s, people were looking at galaxies and they were wondering how those arms could all stay together if the outside arms were going to have to go around so much further than the inside of the arm, and whether the arms were actually arms. And some people were saying, oh no, they weren't arms, they're density waves, they just appear to be arms. And there was, at first, people couldn't even decide which way galaxies were turning. I mean, they're going so slowly that you can't even see them move. And so not only was it a question of how the arms were staying together, it was even a question of which way it was turning. But in later years, we've seen that the arm of stars really is a structure, and radio telescopes have shown that the arms of stars have a magnetic backbone. And there's a guy named what's his name? I can never remember. A fellow that does radio telescopes. And he found that even elliptical galaxies have a magnetic spiral skeleton to them, and so that these star arms are actual structures. And so in 1976, when they found, like, they were able to measure how fast stars are going around galaxies using radio telescopes, and they found that those outer stars are in fact going around the galaxy just as fast as the inner stars. And that was like proof positive that that this was indeed happening, and they needed a reason for it. And they looked back and they saw that Fritz Zwicky had suggested dark matter and invisible matter. And so they decided that there's an invisible matter that's helping these stars go around faster. It's called a flat galactic rotation curve, a flat GRC. And they measure the star speeds from the center all the way out to the edge of the galaxy. And they were expecting those star speeds to get less and less and less as they went out further and further to the edge of the galaxy. But instead, they found that the star speed, the rotational speed, stayed the same for all the way out to the edge. And it made for a flat graph, a flat galactic rotation curve, not even a curve, a flat curve. So these flat galactic rotation curves are what Vera Rubin decided were being caused by dark matter. An invisible matter must be pulling those outer stars around. So that's where dark matter comes from. It's from this need for some reason for the outer stars to be going around faster than they should be, according to our theory of gravity. But that's where dark matter comes from. There's a little problem with that, in that irregular galaxies don't show that effect. In irregular galaxies, that doesn't happen. It's only in disk galaxies that you see this this disk formation that's turning. And that's where dark matter comes from. Everybody's always talking about dark matter.